Master Tron Tamer here. For this episode, we're going to be learning how to terminate large cables, like battery cables or cables for battery backup systems, for whole house UPS systems, those kind of things. I think it'll be great to learn some of the ins and outs of that, and when you're done, you will be a Terminator. You'll know how to do this. So, let's start. So, why? So, you can purchase cables pre-made. You don't have a lot of control over the length. You can see this one's really long. This one actually I picked up at a big box store. And quality, you don't know. You don't know how they did it. Now, I kind of looked at this one, and it's not too bad. What it looks like is that they crimped it down on the wires and then did a little spot weld. So it's probably a pretty good connection. But again, we don't have control over that. And as most of you are probably already aware of, with DC systems, length can be an issue. So having our cables cut to the exact length that we need them is going to really help us with loss. So that's good if we could go ahead and make our own. So that's what we'll be doing in this episode. Okay, so let's go ahead and get started. So for this episode, I've got a piece of 7-gauge wire here. This is leftover from a project that I did, and I'm going to be using it. The project was to put an auxiliary battery in my RV, and as I was looking at the current draw and how much current needed to go through it, it turned out that doing an 8 was kind of borderline with enough current, but a 7 would be great. So they just happened to have a 7. And the other thing that I really like about this particular cable is it's got multiple braids in it. And it's stranded, but it's stranded in such a way that then the strands themselves are individual cords. So this is a really good strong cable. It's pre-tinned, which is going to be good for crimping. So we like that. And it's a pretty good cable. It has a silicone sleeve for the insulation. Now what's good about that is I'm going to actually be going the extra mile on these and soldering them. So we won't have to worry about melting the insulation. Now the silicone isn't quite as abrasive resistant. So if you were going to use some in a situation where you felt like it might get abrased, there are multiple things you can put on top of it. The easiest is just to put heat shrink over it. And that will give it a little extra protection. But let's go ahead and get started on this. A few other little things though. We'll be working with these copper terminals. Let me put a couple here. They're not my favorite to use, but I thought I would use something because I noticed online that a lot of the crimping kits come with these. So this is why I wanted to use them. I much prefer these ones that are pre-tinned. That's going to give me a better crimp, and it's also going to be easier to solder should I want to solder it. And the pre-tinned ones, you could probably, most of the ones you would buy commercially aren't soldered. So it would work just fine for that. Okay, let's go ahead and get going on this. So the first thing we're going to do is get this to the right length. Oh yeah, and there's one more thing I wanted to show you. And you can see it with these two terminals. Because this is 7-gauge, they don't actually make a 7. These are both 6s, and that will work for what I want to do. But the other thing is, you can see they have different stud holes in them. So before you do anything with your terminals, make sure that you've got the right stud size. Go ahead, try it on, whatever it is it's going to eventually go on. because you don't want to mess with that. You want to get ones that are the right size for the bolt that you're going to use. Alright, so let me grab our wire here and we'll trim it. Kind of hold up our connector to it so that we get a rough idea. There. That looks about right. And then we'll go ahead and we'll be slipping this on. Now these ones also have a little bell here on here, and that's to actually help get all the strands into it. So we can go all the way. Oh, one more step before we get going with that. I'm going to go ahead, because I am soldering this later, I'm going to put a little bit of flux inside that connector before I do anything else with it. So I'll just put a little bit right inside the connector. And just in case we might spill it, I'll put that aside. All right. And now let's go ahead and put it in there. Okay, I already see that I probably want to take a little bit more insulation off. I'm going to want to see this wire here. If you were doing a regular crimp and you were not going to solder it, you would want it flush up with the insulation. But in this case, I'm going to be putting in a little bit of solder, and I'm going to need to be able to get at it. So I'm going ahead and just taking off a little bit more insulation so that I have sort of a solder entry point is what it's going to amount to. There. All right. Now, crimping. I wanted to show you 3 different ways to do this. All different costs. So we'll do 3 different examples. Let's start with what is the lowest cost option. And this type of crimping is actually brand new to me. So I'm going to be learning along with you on it. So what we have is a little V valley down here. And then we have boy, it's got a strong spring on it. A little stamp that we're going to stamp into it. So the way this works is you lift this up to get back from the stamp, slide it in there, and then we're going to hit this with a large hammer. So that'll actually be the last one that I do. This is the cheapest option, and like I said, I've never tried one of these before. So I want to see how well that works. So we'll do that one. So that's your cheapest option. Come on out of there. There we go. Next up on cost is this device, which looks a bit like a pair of bolt cutters. For the same reason, it's designed with leverage so that it can put a lot of tension on that potential crimp. And we'll be trying that one out. And then finally, I have a hydraulic kit here where we can do this hydraulically. So we'll go ahead and see all of these in action. But let's start with this one. So I've got this situated, hopefully so you can see this with the camera above. But we actually set this, well actually let me flip it over. We set this by pushing these down, and then we can rotate these to the different die sizes that we want to crimp. And that's 0, 1, and 6, it looks like, is our smallest one. Yep, then we go to 4. So I'm not 100% sure which one of these I want. I'm going to start large because that won't hurt anything. All right, let's go ahead and crimp this. Now I'm going to move this out of the way for now. Yeah, that's a lot better. So we'll go ahead and put this one in and crimp it. It's got a nice positive feel when it goes all the way down. And let's inspect it to see what we got. Actually, that feels pretty good. I think at this point, if I was going to solder, I could just solder it. But if I was not going to solder it, I think I want that just a little bit tighter. So let's see if we can take it down to the 6. Yeah, make sure it's snapped in and that they're going to line up. All right, let's give it another crimp. Well, that was a little bit harder. But that is definitely tight enough. Now, a crimper like this will often put a little extra flange on here, and that's because of the way that the jaws do that. There's actually nothing stopping us from squishing that little part down and getting it so that it's nice and round all the way around. And we would do that simply by putting that part down back in the crimper and doing it again. Yeah, that's a pretty good crimp. So at this point, we would not need to solder that. Like I said, I want to demonstrate that for you, so we will go ahead and solder that. And then, but that's a good crimp. Now we can also bring down this collar area if we want. That will make the heat shrink go over it a little bit better that we're going to plan on putting on there. But for that, we're going to want to go back up to the bigger size. And let me see how that turns out. Oh, I'm not in there straight. That would be my first problem. Yeah, I think that arguably looks a little bit better to put that on there. All right, so that one is done. And we've seen how that tool works. We've got a good feel for that. Let me put this one aside and let's try the hydraulic one. I'm going to need to move the cameras for this because I can't pound this on my table safely. I'll need to relocate for that one. But we'll go ahead and do that one and then kind of evaluate what kind of a crimp we ended up with. All right, so for the next one, we're going to use a hydraulic tool. And obviously, I'll put links to where you can get very similar tools. So this is what the hydraulic tool looks like. It uses a series of jaws that we chase, the dies. Let's see. That's a 6. And that's a 6. Is that? Oh, they have a 7 in this kit. So that's even better. All right. So the way this one works, and I'm going to start with the 6 because it's larger, is these dies insert like this, and then we pump on the hydraulic cylinder and it will bring those together. These work pretty good. The only thing I've not liked about using this tool in the past is if you're trying to work on a piece of cable that's already in place and you try and use something like this, that's actually really difficult because sometimes these dies actually fall out while you're working with them. You know, a little bit of tape or even gum, something like that, might hold that in a little bit better in that situation. All right, let's go ahead and prepare this for the other side. So I'm just kind of sizing it up. And again, it's super easy to trim because it's silicone. Looks like yeah, get that just a little bit more. And let's see how that fits. Actually, we want to take off more. I think that will do it. Oh, I keep underestimating just how deep that is, so. There we go. All right, I'm also going to solder this one. So I'll put a little flux in there. And we'll be soldering in a minute, so I'm going to go ahead and plug in the iron so that it can heat up. Because this iron takes just a moment to come up to heat. It's giving me trouble. There it goes. it's plugged in. All right, so we were going to start with the 6. So let's go ahead and do that. So this works like a hydraulic jack. This releases the pressure. So we turn it on, and now it's ready to pump. Come on. Like I said, they're a little more awkward to use. What I don't like about doing it the way I'm doing it right now is that you can't really see this very well. So let me turn this way. And put this over here so the camera gets a good picture of it. Well, it looks like we're not going to need to go to the next size smaller. The 6 is pretty dang tight on that. Yeah. I don't think we can do any more. So let me let off the pressure. So yeah, that is really on there. There's just nothing like the hydraulic system for getting it tight. So that would be good. Even if we weren't going to solder it, we've got a really good connection there. I am going to try and round this out a little bit. Let's give that a go. Well, that didn't round it kind of how I was hoping, but it did do a pretty good job of bringing that together. It's funny, I think their sizing is a little bit off. Let me grab another die. I want to see what happens if I use the next one bigger. This is actually the one that's marked for 4 gauge. And sometimes it requires a little bit of experimentation. Right, let's see what happens with that one. Yeah, actually I like the results a little bit better with the 4 on there. But good news is we have a nice solid crimp. Yeah, I feel good about that. And both of these would be good to move on to the next stage. Let me move these dies over here that I'm going to do, which is soldering. So let's go ahead and do that. So we're going to need to hold our work. So a little vise or something like that is going to be really useful. And we're going to put it on the insulation a ways back from where we're actually going to solder. Yeah, that should be good. As long as it doesn't move around too much. So these are so large, and this is true, of course, these keep going up because there's ones for 4 gauge and 2 and 0. So as these keep going, it's too much thermal mass to work with a regular soldering iron. So you need something quite a bit beefier than a regular soldering iron. And that's what I have here. This is a Weller. It is an 80-watt soldering iron. So basically 4 or 5 times more than your regular soldering iron for electronics. I like that it has this light down here to tell you that it's plugged in. That could help save you from getting burned. But the thing is I wanted to warn people about is this whole area here is heating element. And it is very hot. You have to be way back here when you're using it. The other thing is it can take more than 20 minutes to cool down after you've used it. So if that's the case, you need to have a good stand, someplace where you can put it where it can cool down after you've used it. All right, so let's go ahead and see if we can get some solder in here. Should not take it too long to warm up. If I get good heat transfer. But it is a big piece of metal. Here we go, we're just about there. Give it another couple of seconds to heat up. It's not going to do any good to force it while we're waiting. All right. Here it's going. It's flowing. And the nature of solder is it loves to fill in little gaps. So it's going to just, without anything we have to do, it's going to flow right into there, in between all those little strands of wire, and also on the connector. It looks like we're getting a little bubble of solder under there. That's not too surprising. Now another thing you could do if you wanted to, and you would put more flux on it if you were going to do this, you would flux up both sides of this, and you could tin it, and that will give it some resistance to corrosion by putting a thin layer of solder on here. But you can see it's really just beating up right now because it needs some flux. So just to kind of demonstrate that, let me put a little on there so you can see how that works. All right, there was enough on the brush. Now, compared to that little bit I just tried, it should go right on. If it's hot enough, and it might need to heat up again. There it goes. And we can look at the other side. Gotta be really careful. It's seriously hot, and will be for a while. Yeah, let's put a little on the top too. Like I said, I just want to kind of demonstrate this for you. And this will help you with corrosion or anything else that's going on with the battery or whatever else you're hooking it up to. This should go right on now. There we go. Now we've tinned it. And that's a really good connection. There's just one step, one more thing we're going to do to this, and that's to put a little bit of heat shrink on it. But we'll go ahead and do the other one while we're waiting for that. I have to be really careful with this, because like I said, it is super duper hot. Hot enough that a bit of extra solder just flung off of it because it was so still so hot. So we could get ourselves a very serious burn. And we need to let that cool, and I'm trying to position it somewhere on my silicone pad where it can safely cool. All right, let's go ahead and do the one that we used with the other crimper. Actually, I want this a little further. Away from the vise. All right, now we know our iron's hot enough because that was working. But I wanted to try something else with you. We could just use the iron like we did before, and I'm actually going to unplug the iron so it can start its very long cool down. I want to show us another way that we could do that. I have here just a little butane torch, and it's another way, particularly if you were in the field somewhere and you needed to put some solder on a very heavy gauge wire. It could do that for you. So let me go ahead and so we use it a little differently, but we're going to sit here and warm it up. Once we get the connector warm enough, and it might actually happen faster than it did with the soldering iron, it will start sucking the solder in. It's just about there. Yeah, now we're there. You can just tell when the solder flows in. And I've got some extra splatting down there. I think I'm actually going to turn this down a little. Oh, look at that. We managed to light up the silicone. Let that warm up. I don't think I have enough solder in there yet. Yeah, this is a better temperature, I can tell already. Cutting down the flame just a little bit. I'm having to put a lot of solder in it because I've got a really thin solder. For work like this, you typically use a much thicker solder because you're going to be putting so much in. Oh, there goes another blob. So, that's yet another way that we could do this. We could do it with a heavy-duty soldering iron. And this is still hot, so when I do this, that solder is going to flip off of there. I've got my safety glasses on so I'm well away from it, and I can go ahead and let that settle. You know, given my choice, I would just use a high-powered soldering iron for that operation. But just wanted to show you that we could also do it with a small torch. And this is a very versatile little torch. I'll put a link in there for where you can get one, and it's not very expensive. All right, so we still haven't done the pounding method. But let's finish one of these ends off first before we do that. And we should be just about right that we can work on that other one. Let's see what size we need. Will this flow over? Nope. We need the next size up. Let's see how this size works. Now you can also use heat shrink of different colors if you're trying to identify something. Yeah, this is the one we want. So to finish this up and make this really first class, now when I try and bend this, it will only bend at this point. Now what this is telling me is that the solder has flown all the way back here, and that means it's also probably gone all the way into the connector. So this is one piece of metal at this point. And then for our heat shrink, we want to at least cover up our connector and then probably go about another 1/2 inch over the insulation. So let's slide that over. And actually, I'm going to get me another piece. I tore that and I don't like how it looks. So let's do that again. All right, so we're going to put that over there. We'll move this to one side while it finishes cooling. Bring over the heat gun. Now we have a good connector ready for installation. Super strong, good connection, everything we want. Now the question is, Is the other side cool enough that I can work with it yet? Okay, we're good. I just get a little bit nervous. So let's go ahead and heat shrink this one too. And I'm also looking for how much solder got in there. And it's stiff all the way back to here. So the solder has flown all the way in there, and it's going to be all the way in here because it goes towards the heat. And this was the part that I had the heat on. So we should have a really good connection on that one too. Let me clean this up a little bit. There. And bring this back. Okay, so we have got both ends of these. We've used the two different methods, and we just have a third method to try, and then we'll go from there. So let's go ahead. This one's still got a little more residual heat than that one, but if I was to touch this baby here, I would get a burn. We need to let that one cool. I don't know how much I can emphasize that. All right, so let me go ahead and prepare a cable for the other one. So I may actually use these in my setup. So if I'm going between a rack, we probably want about that spacing. So let's go ahead and get one ready at about that size. There we go. Actually, I think I'll use this one to put another one of those on. I'll use this side to demonstrate this other one. Like I said, that'll take a few minutes because I've got to go get set up. I can't hit a sledgehammer on my table here. I don't think I would have a table left. So let's go ahead. And because again this is so easy to tear, it's almost the easiest way to strip it. It's just a pull on it like that. So there we've got that. Take a little bit off of there, and we can slide another terminal on there. Yeah, that will work. I think I want to trim this just a little. Not a lot. And I'm not sure if I'm going to put solder on this one, so I'm not going to flux it because I'm really just testing this new way of doing it out. So the way this is going to work is we lift it up. Put it in there, and we give it a good stamp. You know, actually, this one might need solder more than others. Let me go ahead and put some flux on it. Yep. And then again, we're just going to put it in here and give that a good whack. So, that sounds great. Let me go get my camera set up and we'll give it a good hit and we'll go from there. Okay, now that we've gone ahead and used this one, what did we get? Well, we can inspect this, and it's kind of interesting. The bottom of this is deliberately in a roundish V shape, and then certain ridges stick up higher, which are supposed to be part of the crimp. So the back side, I do see that. It did get in there, but on the top side, because of the nature of how it works, it just pounded it. And in fact, pounded a big plus symbol in the middle of it. However, I can't argue with the results. It seems pretty tight. I don't like it quite as much as one that was kind of squishing the wire from all sides like a hex one. But in a pinch, this would work, I'm pretty sure. I would probably want to put solder in that one, so let's just go ahead and do that last step, so we can do that one more time. All right. And our iron should be warmed up because I pre-warmed it. But I think particularly if I was going to put solder in here, I think this one would be fine. And it seems to hold it pretty tight. All right. Just like before, we need to let that warm up just a little bit. I've just put a little solder between it and the iron. The whole purpose is to transfer more heat. Maybe I didn't let the iron get all the way hot. Oh yeah, I did. I put a little bit more solder on the top so that it would help transfer more heat. And that did the trick. All right. Can't see the plus symbol anymore, but that's okay. Go ahead and let that cool down. And then, just like before, we're going to put a little piece of heat shrink on it. I've got one right here. If I try and put that heat shrink on now, well, it's just so hot. Yep, it is. It's going to shrink immediately. So I'm going to let that cool for a second, and then I'm going to give you my observations. All right, so again, this was by far the cheapest option, and I'll put a link in there for it. I think it did an adequate job. It's nice and tight. It seems okay. It's mainly pushing from the top and the bottom, but it does seem to have made a halfway decent crimp. So I'm not going to poo-ha this thing. It worked pretty good. The next option in cost was this type of crimper. And honestly, with the results I got, and if you had budget constraints, I think this is the one I would use. It's got the multiple settings on it, right? And you can start with a large one and work your way down for what you're trying to do. I think it might have issues with super large ones, but like 2s and 0 wire gauge. But it worked great, I thought. I thought it gave me a nice, good crimp. And again, it's a hex crimp all the way around. And as you recall, I rotated it and crimped it again to get rid of the flange and make it really strong. And then finally, your most expensive option would be to get a hydraulic crimper. And a hydraulic crimper like this can crimp any size terminal. I mean, it's got a lot of push power on it. It's got the little issue with sometimes these dies fall out, but other than that, it does it, and it gives a good solid crimp. But it's a lot more money, so you need to take that into consideration. It also makes a wider crimp than this one. Quite a bit wider, like twice as wide. And of course you want as much contact crimp as possible. However, you can use this one twice, right? And crimp it in 2 different places. So kind of how I've come out to this is for everyday use, I think the one that looks like bolt cutters, I think would be fine for normal use. If you're on a super tight budget, you can get these really cheap, and that would be something you could consider. All right, well, in talking about that, we have probably cooled this down enough. Yeah, let's go ahead and we can inspect if we flowed solder in there, and we did. So we've got a really good connection. Doesn't really matter to us that we squished it instead of coming from all sides because we soldered it. And let's finish it up properly. And we've got a nice solid terminal. So I hope that you have enjoyed this video and you have learned something about how to terminate wires so you too can be a terminator and make your own cables, right? Cut them to exactly the length you need. That cuts down the amount of wire, the loss that you're going to have in a low voltage system. And they just look better than what you could buy commercially, and they're going to hold up better than what you could buy commercially. So particularly if you crimp with one of these 3 options and then use solder, you're going to have a near perfect electrical connection in there. So all right, again, have fun with that. If you do this, and particularly if you use soldering equipment, be very, very, very careful. You can burn yourself very easily. And even with these tools, you can have something break. So always have some glasses on when you're working with them. Please be safe. I don't want anything to happen to you. And I think that's great. Don't forget to subscribe, and don't forget to like, and
I'll be back.